Example number 5 is pi over 12 questions. Earlier I said if we looked at our unit circle, we're missing an angle between 0 and 30. Because there's 15 degrees between 30 and 45, 15 degrees between 45 and 60, but there's 30 degrees between 0 and 30, and 30 degrees between 60 and 90. The angle in between 0 and 30 degrees is 15 degrees or pi over 12. And now that we've learned our sum and difference identities, we can use our sum and difference identities to figure out all the pi over 12 family, and that will be another angle you'll be asked to solve for without the use of your calculator. And it used to be, not as much in the last 2 to 3 years, but prior to that, for the last 12 years, there was like not a single exam that didn't have a pi over 12 question on it. No, it's a good thing because pi over 12 questions, like double triangle questions, are predictable. You see one, you do the same thing every single time, which for a lot of students they like because that makes it easy. It's not something you have to figure out. Whereas chapter 6, there was a lot of unit circle questions, like that one quiz that we wrote at the beginning. At the end of chapter 6, beginning of chapter 7, it was sort of like, oh, I have to think so much for every single question. Well, that was more like chapter 6. Chapter 7, with identities, it's more cookie cutter than that. You see a pi over 12, this is how you do it, and you do it every way the same time, and you're going to get it right. So a lot of students like that. So how do we solve a pi over 12 question? All right? Just a simple idea to do it.
Okay.
So simple.
Yeah. And the red part where I labeled even and odd, we're going to look at that a little bit later, but you can label it right now as well. You use your families that you know. You know pi over 3 on your pi plate. You know pi over 4 on your pi plate. You know pi over 6 on your pi plate. And then you try to figure out, is there a way that I could add or subtract to get pi over 12? So in the brackets beside pi over 3, I changed the denominator to be over 12. In the brackets beside pi over 4, I changed it so it would have a denominator of 12. And in the brackets behind pi over 6, I changed it to have a denominator of over 12. So if you look at 4 pi over 12, 3 pi over 12, and 2 pi over 12, can you figure out a way that you could add or subtract to get pi over 12? Can you see 2 different ways to do it? So what is one way that you could get pi over 12? Would you add or subtract? Pi over 3 minus pi over 4. Can you see if you took 4 pi over 12 and minus 3 pi over 12, you would get 1 pi over 12? What's another way that we could get pi over 12? 3 pi over 12 minus 2 pi over 12, which would be pi over 4 minus pi over 6. So what we do to start off is we say, I know that cos of pi over 12 is equal to, and I'll write it with the pi over 12s, 4 pi over 12 minus 3 pi over 12. Same, no, not on your scrap paper, in your notes. And so what that means, if I reduce it, that it's cos of pi over 3 minus pi over 4. And this is an alpha and beta formula. But this time we know alpha is pi over 3, and we know beta is pi over 4. So if we take this, which is the left side of one of those formulas, and rewrite it as the right side of one of those formulas, every single value is on your unit circle. Our cos formula is cos cos plus sine sine when we have cos alpha minus beta. And for these questions, it's going to be really nice that you can use your pie plates for this test. So one thing you should do is in your head, every time you have to do a pie plate question, in your head you should say the answer first. But since you have your pie plate, use it to check, because you don't get your pie plate again on the exam. So throughout this unit, you should be testing your knowledge of how well you have these values memorized. What is cos of pi over 3? One half cos of pi over 4? Sine of pi over 3? And sine of pi over 4? Excellent. So you evaluate each of those. And we have to write our final answer as a single fraction. Right now we have 4 fractions. If you multiplied them, you would get down to 2 fractions. And then if you added them, can you see that they will have a common denominator of 4 already? And so we can add them, root 2 plus root 6 on the top, all over 4. Sometimes on exams, we just figured out cos of pi over 12. Sometimes on exams, they have a part B worth 1 mark. Oh, I don't have it here yet. Okay, I'll do it later. We'll do one in degrees. 75 degrees, which is the same as 5 pi over 12. But you wouldn't change it to 5 pi over 12. You would just do this one in degrees. Is there anything on our unit circle that adds or subtracts to give you 75 degrees? Yes. (45 degrees plus 30 degrees). So our formula with alpha plus beta with sine looks like that. And all of a sudden, all of those values are on your unit circle. So once again, you can evaluate them and get your answer. So before we figure out cos of 17 pi over 12, you're going to put 17 pi over 12 on your scrap paper, and you have to think of your pie plate, and you can use any pi over 3, any pi over 4, any pi over 6 in any quadrant, anything coterminal with any family member, and you have to find out 2 things that add or subtract to get 17 pi over 12. And the rule is you have to find one different than somebody else. So if you find one, put up your hand, I'll put it up on the board, and then that one's off. Then you have to find a new one. There's an infinite amount of ones that work. There's an infinite amount of ones that work, but you have to find one different than somebody else. Because the hardest part in these questions is exactly this, finding 2 that work.
So it has to subtract or add.
Or add to 17 pi over 12. And you can use anything on your pie plate, and it's non-calculator.
But it's not.
Here are the 8. I'll add the one that I came up with that I thought no one would come up with. So I had also 25 pi over 4 minus 29 pi over 6. You can multi-revolution whatever you like. Right? Because we've got some here that are past the first quadrant. We have a lot that are just in the first time around. This one is, this one is, this one is, this one is. Okay? But what do they all have in common?
I absolutely have 0 and
Zero idea. They're all in the unit circle somewhere. They all have, you're right, they all have pi over 4s. You can't make a single one without using something in the pi over 4 family. So if we look at all the pi over 4 families that have been used, is there any pi over 4 family that hasn't been used yet? We've got pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Seven pi over 4. Do we have a 9 pi over 4? 11 pi over 4. Do we have a 13 pi over 4 up there? No. So someone could have used 13 pi over 4 and figured out if we had to add or subtract to make it work. Well, 13 pi over 4 is the same as 39 pi over 12. What would you have to subtract to make 17 from 39? You'd have to subtract 22 pi over 12, and 22 pi over 12 reduces nicely to 11 pi over 6. So every time you use something from the pi over 4 family, you will always get something else that reduces nicely on your pi plate. If you don't use a pi over 4 family, it won't work out. And the reason for this was something we had on our previous slide here right at the beginning, is that the pi over 4 one, when you look at it over 12, is the only one that's odd. The other two are even. And if you do an even number plus an even number, you will get an even number. And if you do an even number minus an even number, you will get an even number. But all of our pi over 12s will be an odd number times pi over 12. Because if I gave you an even number times pi over 12, like 16 pi over 12, what could you do with 16 over 12? Reduce it, and then it's part of your pi over 6 family, and then it's easy. So we always have to use a pi over 4. And then it does not matter if you get to cos of 17 pi over 12. It does not matter which one you use, your answer will work out. So I decided here to use, right, it says start with any pi over 12. I decided to use the 21 pi over 12 minus 4 pi over 12. And when you're starting with any family member, you can change all your pi over 4s to be something pi over 12, and I suggest starting by writing it. I chose 7 pi over 4. I wrote 21 pi over 12. What would I have to do to get 17 pi over 12? I'd have to subtract 4 and then reduce them. What do they reduce to? Well, the one reduces to 7 pi over 4. The other reduces to pi over 3. I know some students who always just start with pi over 4. They don't even try to get close to the number they're finding. I'm just going to start with pi over 4, which is 3 pi over 12. What would you have to add to 3 pi over 12 to get to 17? 14 pi over 12. And that reduces to 7 pi over 6. So some people like to start with one that's close. Some people like to start with always pi over 4. Some people like to start with what's close and then add instead of subtract, because they're better at adding than subtracting. But all of them will work. The thing that starts to happen once you get to bigger ones, like here I have cos of 7 pi over 4 minus pi over 3. When we plug that into our formula, we have to also remember our cast rule. 7 pi over 4 is in what quadrant? It's in quadrant 4. So will cos be positive or negative? Positive. But what will happen with sine? Sine will be negative. So when you're figuring out your values, not only are they going to look at your actual values in each of those brackets, but to make sure that you have the signs correct. And so in this example, once we write it as a single fraction, we get the square root of 2 minus the square root of 6 over 4. So once again, a root 2 is present, a root 6 is present, and it's all divided by 4. I can go up a little bit, yeah. Is that okay? So on the exam, a very typical part B to this question would be, can you find secant of 17 pi over 12? So you figured out cos of 17 pi over 12. To write secant of 17 pi over 12, you just take your answer and do the reciprocal. And you would get full marks if your answer in A was wrong, and you flipped whatever you got, you get full marks for B. Because they're just checking to see if you understand that secant is the ratio is the reciprocal. It used to be on exams, sometimes they would just ask, find secant of 17 pi over 12. And if students didn't think to first find cos of 17 pi over 12, they would get like 0 out of 4. And they felt bad for those students. So over time, they've made it easier by asking cos of 17 pi over 12 in part A. And if you don't know how to do that, well, that's your typical pi over 12 question. And then in part B, they ask secant to see if you can flip it. So on your scrap paper, or if you need new scrap paper, you can go grab a new one. Here's an old exam question which added a little thing that was a little bit different. So I want you to try this one on your own. Determine the exact value of 4 cos 11 pi over 12. So here's a check if you did cos of 11 pi over 12 first. Did you get negative root 2 minus root 6 all over 4? So the question is, what is the effect of having a 4 out in front? What does that mean? It means multiply. Whatever answer we get would have to mean multiply. Now, if you wanted to show there's two ways of going about this. One way is we could do cos of 11 pi over 12 first, and then underneath say, well, then 4 cos of 11 pi over 12 is equal to 4 times this. And your 4's would simplify, and you would just get negative root 2 minus root 6. That's one way you could show your work. You find the black first, cos of 11 pi over 12 first, and then say, since I now know what cos of 11 pi over 12 is, I could multiply by 4. That isn't crazy, but so many students left this blank because of the 4 in front, which technically means that so many students don't know how to multiply by 4. That is a mathematical concept that's too hard for grade 12. Okay? Sometimes we have to take a step back and just ask ourselves if something is different. Because the main reason that students left this blank is because the 4 was in front, and to them, that was something that was different. Because they'd never seen a question with a 4 in front before. So it was different. When something's different, you just have to ask, well, what is the difference, and what does it mean mathematically? In this case, it means multiply by 4. And then you have to ask yourself, have I ever multiplied by 4 before? Do I know how to do that? If I have an answer and I need to multiply by 4, could I do that? And all of a sudden you realize, yes, this question isn't that much harder. But if you just go by looks, it looks different, so then people stop. Don't just go by looks. Ask yourself what it means. The other way to do this, and I'll just add it in here, if you wanted to have the 4 out in front right from the beginning, well, then the 4 would still be here. It would still be here. Now that you've expanded, you would need to have brackets around there. Keep that 4 with brackets around there. Keep that 4 with brackets around there. And then you could simplify there. It's the same thing. You're just multiplying by 4 right from the beginning. Right? It's still 4 times this, 4 times this, 4 times all of this, 4 times all of this, 4 times all of this. And it would simplify the same way. A 3? It could be. They could put any number out in front.
37.
Literally how?
It's the same thing. You just put it in front and distribute it if you'd like on the top. Or leave it out in front. It would be the same thing.
If you didn't like simplify, like if you had 4 bracket negative root 2 minus root 6 over 4 close bracket,
You wouldn't lose marks because you don't lose marks for not simplifying.
excellent.
Yeah. So this question wasn't that bad, but it does point out a common flaw that sometimes people have in learning math is when something doesn't look exactly the same, I can't do it. When something doesn't look exactly the same, ask yourself what's different. Ask yourself what you could do if it was simpler. Like you could do the cos of 11 pi over 12. And then say, well, what does a 4 in front mean? It just means multiply. So your question for homework on this one is number 7.